We're now going to turn our attention to some more transforming operators in the Flux class. If you recall, we talked about the map transforming operator. And now we're going to talk about the flatMap transforming operator. And this is a really powerful operator. It's very popular. It's very widely used. If you program with Project Reactor, if you program with RxJava, you've absolutely got to understand how flatMap works. And we'll also talk in the next part of this lesson about how flatMap compares and contrasts with map. So let's first start by talking about flatMap in its own right. So what it does is it transforms the elements that are emitted by this flux, typically in some asynchronous way. There's ways of using it that's not asynchronous, but it's very commonly used in an asynchronous context. In particular, the elements that it emits are emitted into something called inner publishers. And you can see this particular function, which is the mapper, has this inner publisher capability here as the second parameter to the function. So what happens is each input element that's coming from the prior flux, part of the stream, is then being mapped to some publisher in some way or another. And that publisher will then emit one or more items. It actually could emit 0 or more items. I should probably change that, because you don't have to emit anything. And that's one of the things that makes flatMap different from map. You don't have a one-to-one mapping. The inner publishers are flattened by flatMap into a single flux by merging. And I always like to use the image of a steamroller that's going to roll over those values and flatten them out. As a consequence, these elements can interleave. And this is especially true when we use concurrent processing. And we're going to talk through the flatMap concurrency idiom here just in a moment, which is a very common way in which things can be interleaved. So if you look at the video, if you look at the image here, you can see that we have a couple of different values that are coming in. That you have some things coming into flatMap, and then flatMap can also generate some other stuff. And so you can end up with interleaving of the values that it's processing and publishing. It has some similarities and differences compared to map. The similarities are that flatMap can transform the values and/or the types of elements it processes, just like map. It's the same in that respect. However, the number of output elements may differ from the number of input elements. So you might end up with more output elements than input elements. You might end up with the same number, or you could actually end up with less elements if you're going to end up eating some of the elements and suppressing them in some way or another. We often use flatMap for triggering concurrent processing. And this is what's known as the Project Reactor flatMap concurrency idiom. It turns out that there's also an RxJava flatMap concurrency idiom. We will talk very, very briefly about that. Same basic idea. And you can use this in order to be able to do some type of embarrassingly parallel processing. So let's take a look at a very simple example. And we'll take a closer look at this in the source code when we get to case study EX3. So what this is going to do, this particular example is going to take a big fraction. We're going to go get a big fraction. And this is going to then subscribe that to run on a scheduler. And then what we're going to do is we're going to have this intermediate flatMap, which is going to take this flat fraction, and it's going to go ahead and reduce and multiply it and do that in another context, another scheduler context. So this is going to run in a concurrent way. And we'll talk about that when we get into the example here. RxJava has a flatMap operator that works in exactly the same way. And all these things are syntactically similar to Java Stream's flatMap operation. And you can see here where we have a list of strings, two lists of strings, and we can take both of those lists of strings and we can of them, which will make a stream of lists of strings, and then we can flatMap them so that there'll be a stream of strings, not a stream of lists of strings, and then we sort and print them out. The most important thing to remember, however, is that flatMap in streams doesn't support parallelism, unlike flatMap in Project Reactor and RxJava. So you have to do other kinds of things, like use the map multi-operator as a convention, an idiom of being able to work around the limitations of flatMap with parallel streams. flatMap doesn't ensure the order of the items in the resulting stream. They can be in different orders. If you really need to have order matter, then you need to use concat map. So that's the end of the first part of the discussion of flatMap. In the upcoming next part of the video, we're going to talk about how flatMap compares and contrasts to map.